You spin up a Kubernetes cluster, maybe it's AKS, EKS, GKE, maybe it's on-prem, whatever it is. Regardless of how you're spinning it up or where you're spinning it up, there are always some subtle differences. So Kubernetes is Kubernetes underneath the hood, but how Azure packages it, how kubeadm packages it, how EKS packages it, it's all going to be different. And because of that, attack paths may be different. And when I say attack paths, I mean, what can attackers, bad actors, hackers do in your environment to get to where they want to get to? Chances are they want to get to etcd or pods that contain containers, which have your application stack. So I came across a cool tool called KubeHound, and it's an open source tool from Datadog actually. Datadog has another cool one as well that's called Managed Kubernetes Auditing Toolkit. And we'll talk about that maybe in another video. So KubeHound essentially gives you this graph of sorts to kind of see the attack paths that a potential bad actor could take. So let's take a quick look at how we can set this up and configure it in any Kubernetes environment. All right, so the first thing I'm going to do is I'm going to do a wget on one of the latest releases, and this is the release link. Notice here how I'm using ARM because I'm on an ARM-based Mac, but there are releases for AMD 64 based architecture and Linux based and all that good stuff. So go ahead and run that. All right, I'm doing ls here. Beautiful. I'm actually going to this one here because that was an old version that I was playing with. All right, we'll do KubeHound, and I'm just going to change the name to KubeHound. All right, we'll do an ls here. Beautiful. Do a chmod so we can change the permissions for the binary so we can run the binary and then give it a shot. All right, let's kind of see what's happening here. So I am using an AKS cluster. So it looks like it's pulling some information from there. It's building a graph for me. And one of the things that I'm curious about, I didn't really see this in the documentation, but it's pulling attack paths, but I wonder like how it knows what those attack paths are, because again, if you're deploying kubeadm versus AKS, yeah, it's all Kubernetes underneath the hood, but it's configured in a different way. So it must be scanning against some database, looking at overall Kubernetes best practices maybe, but yeah, because again, the Kubernetes binary code base underneath the hood is the same for AKS, EKS, etc. But they modify it in a way that works for their cloud platform. So to be able to know the attack paths, it's going to be different based on environment, I would assume. Now, really quick, something to show here. If you do not have Docker running locally, it looks like it is spinning up a container, or at least one container locally around caching with Redis and Mongo, I believe, to pull the configurations and store them somewhere and then show them to you locally. So you're going to need Docker desktop running. All right, now one thing I noticed here, I tried to run this once, it didn't work properly, and I restarted Docker, and I'm not sure if that fixed it or if pointing directly to my kubeconfig fixed it. Now, typically any Kubernetes related tool is just going to look at your current context, but maybe KubeHound doesn't work that way, and this is what, kind of got it working. So as we can see, we got a warning here, about to dump k8s cluster AKS environment 01. Do you want to continue? Yes. All right, so now I believe it's going to start looking through all the authentication, all the authorization, all the pods, everything and anything. And this was pretty quick because this is a brand new AKS cluster. But of course, the more service accounts, pods, authorizations you have running in your cluster, the longer it's going to take. All right, we can see it was complete. Please visit the UI to view the graph by clicking the link below. Awesome. Password is admin. All right, let's go ahead and log in. Okay, clusters. Okay, so this is all running Jupyter Notebooks. If you're not familiar with Jupyter Notebooks, you'll see it a lot in like the machine learning realm or the AI realm. Really, a notebook is like another place to run or write and run and execute code. So like, for example, if I had some Python code and I didn't want to execute it locally, I could do it via Jupyter Notebook. All right, so let's click on the files here. All right, so heading back over to the docs really quick, we can see to query the KubeHound graph data requires using the Gremlin query language via an API call or a dedicated graph. And then we can see here that it does in fact give you one by default. And we were kind of talking about this in the beginning here, but when you click on this, it brings you to a 404. So let's try to access it just like this maybe. We'll do a run here, run. Okay, cool. So now we're starting to see a little bit of information here running this. So, okay, it looks like the goal is to, under KubeHound, you're going to open up this Jupyter notebook and you're going to run the code within the notebook. And then we can kind of begin to see some information here that's coming out. And there are a couple of methods for critical path, element map, and then limit to 100 for the results. Okay, cool. So if we take a look, we could see some of the resulting data here. So now, for example, if we're taking a look at the top one here, namespace kube system port 10091, service endpoint, npm metrics cluster. These are default service endpoints directly from AKS. And then it's giving a 0 for compromised. Okay. Now, if I go to graph, we can see some information, and this could like look a little bit confusing at first. But like, for example, let's say I click on endpoint and I click on this little hamburger here. We can see the node, the address type, the app, if it's compromised, what the exposure is, the namespace that it's in, port, etc. So if we wanted to, for example, like understand, okay, endpoint exploit. Well, there's this attack reference. And if I just type in endpoint exploit, we can see represents a network endpoint exposed by a container that could be exploited by an attacker via means known or unknown. Okay. Now, if we go a little bit deeper in here and I click on the container, okay, notice here how it tells me the container, the capabilities, the cluster that it's running on, of course, whether it's compromised, the image. So this, unfortunately is coming directly from Azure. So this is an image that's deployed automatically for container networking on AKS once AKS is deployed. Again, remember how we were talking about the whole Kubernetes is Kubernetes, but it's modified a little bit underneath the hood per environment or per cloud, like Azure, GCP, AWS, whoever's deploying it. These are the kind of things that we could run into. And then if we dive in a little bit more, we can see that there is a volume discover. So if we go back to the KubeHound documentation here, volume discover, what does this mean? Represents an attacker within a container discovering a mounted volume. So volumes can contain Kubernetes API tokens or other resources useful to an attacker in building a path. So if we come back here, we can click on this volume here, and we can see again where this is coming from, the source path. Dive in a little bit more. You can see exploit host write. I'm assuming that means writing something to the node because it's directing the node, but let's see. Exploit host write. I want to exploit host write. Going directly to this AKS node right here. And then what does this mean? Exploit an arbitrary write from a sensitive host path mounted into the container to gain execution hosts, all right? So if a sensitive host directory is mounted in a container with write permissions, there are a huge variety of attacks that could essentially occur. So what this is telling us is by default, this container is mounted to a particular volume, and that has the vulnerability to exploit host writes to the node, okay? And then as this is saying, it's a sensitive, if a sensitive host directory is mounted in a container which we're seeing that is what's happening in this graph here. With right permissions, there is a huge variety of techniques to achieve execution within a container. Now, what does this all kind of mean? It means that this container has the potential ability to break out and write configurations to our node. So yes, by default, we know that, Kubernetes is insecure. We know that there isn't a lot of security happening by default, and we want to be able to mitigate it as much as possible. The question is, what can we mitigate? This is a container that has an attack path via a volume to the node, but this is by default deployed via AKS. So it's all going to come down to what you can mitigate. And remember, security is all about mitigating as much as possible. You're never going to mitigate everything, but this graph will at least give you some information on what attack paths are out there and what's available.